All right, this is going to cover coterminal angles and reference angles. When we rotate around a circle, we either go clockwise or counterclockwise. Counterclockwise rotation is for positive angles. Okay, and if we spin clockwise, then we're going in a negative direction. Okay, so here we're going to draw each of these angles one at a time. To draw 4 pi sevenths, we always start at 0 degrees, which is located directly to the right of 0, 0. Here's our starting position, or our initial side of our angle would always be the x-axis pointing to the right of 0, 0. If we go halfway around the circle, that's pi radians. But in order to have a common denominator of 7, we're going to put 7 pi over 7. Halfway to pi would be half of that, or 3.5 pi sevenths. 3/4 of the way around would be 10.5 pi sevenths. 4 pi sevenths has got to be just a little more than 3.5. So our terminal side would be in quadrant 2. So a rotation of positive 4 pi sevenths would be a counterclockwise rotation into quadrant 2, just a little more than a quarter way around the circle. All right, let's do the same thing for 7 pi fifths. Halfway around would be 5 pi fifths. Quarter way around would be 2.5 pi fifths. 3/4 of the way around would be 7.5 pi fifths. And we always start at 0 degrees, or 0 radians. So our initial side would be always pointing at 0, and our terminal side would be almost 3/4 of the way around, rotating in a counterclockwise direction because it's a positive rotation. Remember that positive rotation goes counterclockwise and negative rotation goes clockwise. Okay, let's go with 19 pi elevenths. We always start at 0. Halfway around would be 11 pi elevenths. Quarter way around would be 5.5 pi elevenths. 3/4 around would be 16.5 pi elevenths. All the way around would be 22 pi elevenths. So 22 pi elevenths would be the same as 0 radians. So 19 would be somewhere in the 4th quadrant. And we would rotate counterclockwise to get there. Doesn't have to be spot on. It just needs to be in the right vicinity of where that angle should be. All right, this next one's a negative angle, so it has to rotate the opposite direction. Instead of rotating counterclockwise, this one's going to rotate clockwise when it's negative. We still start pointing at 0 radians. But now, when I rotate around, let's see, well, halfway is still the same. This will be negative 9 pi ninths. Would be halfway around. Half of that would be what, negative 4.5? So negative 5 pi ninths would be somewhere down in here. Rotating clockwise because it's negative. Degrees, I think, are a little easier because we're used to those numbers. We've been using degrees for years. Radians are a little newer to us. If you need to, with degrees, just look at your unit circle. Most of these are on the unit circle or really close to something that is on the unit circle. So 235, if you look at your unit circle, is pretty close to 225 or 240, somewhere in between there, which we know is in the third quadrant. Because it's positive, we rotate counterclockwise. Okay, 305, just look at your unit circle, is really close to 300 degrees, which is in the fourth quadrant, and we rotate counterclockwise. 115 is pretty close to 120. And counterclockwise. So when you draw these angles, you have an initial side and a terminal side. You always have the initial side pointing in the direction of 0 degrees or 0 radians, and the terminal side pointing at where you stop. Okay, 78 is going to be somewhere between 60 and 90. So we have our 0 and somewhere between 60 and 90. And again, this one's counterclockwise because it's positive. Okay, let's talk coterminal. Coterminal angles are angles that start or stop at the same spot, but have different number of revolutions. So you can spin around the circle more than once.